So this is the first video covering activity 3.9. In this video, we're going to use logarithms to solve exponential equations. We started that topic in section 3.8, but we're going to take it a step further with this activity. So if you look at example 1, it says solve the equation 25 times 1.2 raised to the t equals 230. So the first step is to isolate the exponential. All right, so the exponential is this 1.2 raised to the t. So I need to divide both sides by 25, okay? So when I use the word exponential, the exponential piece is what's attached to the exponent, right? So the exponent's t, so we want to isolate the 1.2 raised to the t. And we do that by dividing both sides by 25, right, down here. All right, so step 1 is done, right? The exponential is isolated. We have 1.2 raised to the t equals 230 over 25. So the next step would be to take the natural log or the log. So in the example here, they used ln. I could also use log on both sides, and we'll still get the same answer, okay? So they take the ln of both sides, and then we can rewrite using properties of logs, right? So from the last section, you remember, if I have a log with a raised to a power, I can bring the power to the front of my log. All right, so if I call this, let's say, step 1, and this is step 2, step 3 would be rewriting using properties of logs, right, where we bring the t in front. Right? And then to kind of finish the problem, we want to get t by itself. We're trying to isolate t by itself. So if I divide both sides by the natural log of 1.2, we end up with t by itself. And I just want to verify with my calculator. So I enter the natural log of 230 divided by 25. And then I'm going to divide this entire piece by the natural log of 1.2. Oops, an extra set of parentheses. I think it would work with the extra set, but I will delete it. Okay, there we go. And then I press enter. And you see I end up with 12.1719, which is what the book gives us. All right, so that's how we solve an equation that looks like this. Remember, we could always just graph both sides of the equal sign, and the intersection would happen at 12.1719. Or we could use algebra, which means we solve this using logs, okay? Now the book says, hey, you know, if you really wanted to check your answer, we could substitute whatever answer we just found, this 12.1719, in for t. And if we were to do 25 times 1.2 raised to the 12.179, we should end up with 230, right? So the quick check would be, let's see here, 25 times 1.2 raised to, and now I'm going to put, so I don't have to round. If I want to put this entire number here, I'm going to put the word answer in here. So if you look, I'm going to move my calculator around a little bit. If you see underneath the minus sign or the negative sign is the in blue, you see answer or A and S. So if I press second and this negative key, it says answer, right? So 25 times 1.2 raised to my last answer. My last answer was a 12.17192044. Press enter, and we get 230. See, if you were to round, right, let's say you put in 12.1719, you wouldn't get the answer 230 exactly. It might be off by a point or two. All right, and then of course, graphically, we could graph both sides of the equation. I'll do that quickly. So if I press y equals, remember our original equation was 25 times 1.2 raised to the t. So I'll type it exactly the way you see it. 25 times 1.2 raised to the x, and then y2 would be the 230. All right, so we're graphing the left side of the equal sign, the right side of the equal sign. Now, in terms of the window, remember, we're going to have a straight line at 230. So when I press window, I'm going to go from 0 to, say, 15 on the X. But on the Y, I just need a number that's a little bit bigger than 230. So maybe I'll use 300. I press graph. And the intersection should happen at 12.1719. Okay, so to get the intersection, if you recall, we press second, trace, number 5 for intersection. We have 2 curves, so we has enter, enter, and then our guess, enter. And the intersection happens at 12.17192, which is what we have down here. So we've actually solved this example 3 times. We solved it with logs. We solved it by graphing. And we solved, or we actually just verified our answer with the check, right, by putting in that 12.1719 in for T. So we didn't actually solve it 3 times. We solved it twice, and then we performed the check. Now, let's take a look at example 2. Well, it looks like we have a similar problem, right? So e raised to the negative 0.012t. Now, some people, they see this letter e and it causes problems for them. Just remember, e is really a number, kind of like pi, right? If I press second and the caret key, you see pi. I press enter and you see that pi is 3.14. If I press second and the number above the division key, that's e, you get 2.718 and so on. So really, e is just a number, okay? So in the next video, I'm going to actually solve example 2. All right, so I want to stop here and look for the next video to see me work through this example 2 for you.